All right, so today we're going to talk about systems of equations, matrices, and a bunch of other fun things. Real basic, but fundamental. For I think where I'd like to start off is, of course, understanding the game plan. The game plan is real simple. We're going to understand this word here, Echelon, some of the famous tweaks that you can do to get it into Echelon form. And of course, how is this related to matrices? So first, the word echelon, of course, it has different meanings. If you look it up on the standard dictionary, but the meaning that we're interested in is this specific one. Formation in rows where each end of the row is projecting further than the one in front. So here, the birds also fly in echelon form. So you got this pattern here where each row projects on further than the previous one. That's an echelon formation. And we see it here with equations too. This would be a not echelon. It's just a big old box. This would be echelon form because it's got that pattern here as described on the standard dictionary. This is echelon. This is not echelon. Now, this would be a typical system of equations. A system of equations is a bunch of variables, x, y, z, for example, in this case, and a bunch of equations, one equation, two equations. So this is called a 3x3 system, meaning it's got 3 equations and 3 unknown quantities, x, y, and z. So this is your typical system. And so we would say that this system is not in echelon form and this system is in echelon form. Now, what the hell is the big deal with echelon form? The big deal is that this system over here is a piece of cake to solve. You could solve it with your left hand, even if you're right-handed. This system over here, not so easy to solve. Maybe it requires a bit more brain. And you've done these things when you were in basic algebra classes, probably when you were in middle school or high school. So I suspect it's nothing new to you. We're just trying to review a bit of the vocabulary, maybe, and maybe look at these in a slightly more modern way or more advanced way. If you've never seen them since high school. Here we go. Let me tell you why echelon form is so good. So it's so good because the bottom equation, since it's got no x, no y's here, and it's got no x's here, all it has is z's. That means it has only one variable, and it's super, super easy to solve. So already I can tell you that the z value is equal to 7 because it's right there already. And then you can take this one and put it up here and substitute it. Well, more likely you would substitute it into the z value into the 7. Then you get that y plus 7 is equal to 8. And immediately that would tell you that y is equal to 1. So y is equal to 1. So far I spent about 10 seconds solving this equation. And I've already got 2 of the variables down. That's how good I am. Then the third variable, we will take the third equation and substitute it there. And we'll take our y value and substitute it there and our z value and substitute it there. So that our third equation becomes x is, or x added to 2 plus y, which is 1, plus z, which is 7. That's equal to 8. So x plus 2 plus 7 is equal to 8. So x plus 9 is equal to 8. So x is equal to negative 1. So x is equal to negative 1. So that's why whenever you're given certain systems of equation, if you had to choose what kind of system you want to solve and you're kind of lazy about it, you would want this system. These are so easy to solve. This is the easiest thing in the world. Solving linear echelon form systems. Everyone can solve them because all you do, your bottom one is already done, substitute it back. Now you got 2 variables, substitute it back. You'll be done in 30 seconds. This, not so easy. Okay, then you got to do all your things that you learn in high school. Kramer's rule, substitution, graphing. Probably a bunch of those techniques. So today we're going to learn a new one. And the brilliant idea for today is, wouldn't it be nice if we could convert all of these into echelon forms? What we want to do is talk about converting or maybe tweaking this system so that it looks like that one, and then everything will be easy. That's the idea for today. Can you tweak a non-echelon form system into an echelon form one? And what would be allowed? First of all, it should be obvious that the systems or the solutions are not going to be affected if all you do is reorder the equation. If you reorder the equations, for example, suppose I reorder these ones. That would give me the following system: x plus 2y plus z, that's equal to 5. And that would give me that y plus z is equal to 8. And that would give me that c is equal to 7. So what I've done here is just reorder. This is the same system, different order. Same system as that one, different order. But now the thing that I have going for me is now I've got the echelon form, and now it becomes a piece of cake, a walk in the park. That's why sometimes this business of reordering the equations actually makes things a lot easier for you. The other two things that maybe are kind of obvious, but that you can also do, yeah, they're super obvious. First of all, you can multiply any equation you want by a non-zero number. So for example, I could, in theory, I could take this system and I could multiply this one. I can multiply this entire equation. I'm going to multiply by 3. And that would... What? Should. I hope you guys are not listening to this. Okay, I don't know what's going on. Sorry. Siri's talking to me while I'm trying to record this video. Sorry. All right, so I'll multiply this by 3, and so I get 10x plus 20y plus 10z, that's equal to 50. Okay. And this would become 3x plus 3y plus 3z is equal to 24. I multiply this one by 3, multiply that by 3, multiply that by 3, multiply that by 3, multiply the entire equation by 3. Everything on this entire equation multiplied by 3. And so once you distribute it, that gives you this piece right here, 3x, 3y, 3z, and 24. And you copy everything else the same. Negative 3x plus y, plus z, and that's equal to 7. You should realize that the new system that I've got here, this is still equivalent to the old system. This system right here is the same system. And by that, I mean it has the same solutions as that one. It's not completely the same because it changed one of the equations, but the change was so trivial. All I did is rewrite the equation by multiplying everything by 3. Notice I could undo that by multiplying everything here by 1/3, and that would get me back to where I was. Yeah. But the point is that you could, if you wanted to, multiply by 3 or multiply by any number. And you might ask, well, why would you want to do that? Sometimes you want to do that because another thing that you could do, I could combine these two equations, somehow combine them. We don't really combine them, but I could, for example, add the second equation to the third. So we could add to the third equation 1 times the second equation. If I do that, that would give me the following. So I'm going to leave these two alone. These two equations, they stay the same. These two, they stay the same. All I'm doing is changing the third one. What am I going to do? I'm going to add 1 times that entire row, and I'm going to add it to that one. So this one will be the new resulting combination of that one and that one. That's going to give me the following. The first two are not changing, so I might as well go ahead and write them. That would be 10x plus 20y plus 10z. And that's equal to 50. The next one is not changing, so that would be 3x plus 3y plus 3z, and that's equal to 24. And the last one is going to be 4y. That's what happens when you add the 3y here. Whoops. The 3y and the 1y, that gives you 4y's. If I add these ones, you get 0x's, so there's nothing there. If I add these ones, I get 4z's, and if I add these ones, I get 24, I get 31. So that would give me 4y plus 4z, and that's equal to 31. Okay. And of course, that's kind of nice. It's got a little bit more of an echelon feeling, right? So by making these type of little tweaks, you could, in theory, keep modifying this equation, keep modifying them, keep modifying, making small little tweaks until you get to the echelon form, like this. And that would be nice. And so we summarize here the things that you can do. These are the tweaks that would cure the non-echelon equations, right? First thing you could do is reorder. The second thing you could do is you can multiply any equation by a non-zero constant. Third thing you could do is you could add to any equation a multiple of another equation. That's the example of what we did just now. All right, let's finish this just for fun. Another thing I can do is I can see that 10 goes into all of these, the number 10. So I can multiply everything here. The entire row I'm going to multiply by 1 over 10. That should get rid of that. All those kind of annoying numbers. So that would give me x plus 2y plus c is equal to 5. I'll leave this one alone. Well, actually, I could multiply this one also. I'm going to do 2 of these operations on the same one. I'm going to multiply this by 1/3 just for fun. Why not? It's legal. I can multiply the entire row by 1/3, so that would give me x plus y plus z, and that's equal to 8. And the other one, I leave alone. 4y plus 4z, and that's equal to 31. See? And another thing I could do is I could add to this row. See, I don't like this x on the bottom. I wish this wasn't here. If this was not here, I would already have closer to my echelon form. What you got to do is you got to start with the first item here and get zeros below, so there should be nothing here. Everything should be here, and then cleared, on here. And then the y is okay, but you want this one cleared. That way I'll have the echelon form. That's what I'm trying to do. So next target is this guy. This guy's annoying. I got to get rid of this one. There's like a million different ways to get rid of it, by the way. Here's one simple way to get rid of it. First thing that comes to mind is take this guy and add to it 1 times row 1. So I'm going to take row 1 and I'm going to imagine 1 times it. Oh, sorry, -1. I meant -1 times row 1. That way, this will be a -1x times that will give me 0. Negative that will give me -y. Negative that will give me 0. Negative that will give me about 3. And so this is the only one that I'm modifying. So I leave the other ones alone. I'll write them alone. Write them again so that I can emphasize for us the fact that the other ones are not changing. X plus 2y plus z, that's equal to 5. 4y plus 4z, that's equal to 31. And here we're going to get, if I do -1 times that and add it to that, that gives me 0. If I do -1 times that and add it to that, that gives me -y. If I add -1 of that times that, add it to that, that gives me 0. -1, that gives me 3. And so that will give me 0 on the first spot, -y on the next one, 0 y's on the next one, 0 z's on the next one, and of course 3 on the last one. And so that's almost perfect. I'm done with the x's. Notice there's no more x's below, so I'm part of that. I'm done with messing around with that one. Now I want this one to be 0. So one way to get that to be 0 would be to add to this one. To this one, I'm going to add 4 times row 2. Yeah, sometimes I'll just R. Row 2. 4 times row 2. So think about it. I'm going to do 4 times this. That times 4. That was giving me -4y. When you add it to that, that'll give me 0. 4 times this. and that will give me 0 z's. Added to that, that'll give me 4 z's. And 4 times that will give me 12. Added to that will give me 43. So this will give us a total of, I'll just go here. First row is not changing, by the way. Leave the first row alone. No problem. So that'll give me x plus 2y plus z is equal to 5. Second row is not changing, so it'll give me negative y plus 0z, that's equal to 3. And the next one's going to be 0y plus, 4z, and that's going to be equal to, we said that 4 times this is 12. 12 out of that is 40, 43. And of course now, look how beautiful this is. Now I have the exact echelon form that I wanted. And that's amazing. That's how you take a non-echelon one and you make, small modifications until you get to echelon form. That right there is beautiful, because now remember what we said at the beginning of the lecture today. These ones are a piece of cake. You can just back substitute and you'll be done in 10 seconds. These ones not so much a piece of cake. The key to make the cure for the non-echelon forms are exactly these operations. Reorder the equations whenever you want. Multiply any equation by any non-zero constant. Add to any equation any multiple of another equation. Okay. And by the way, these things are super fancy and super famous. These are called elementary row operations. Okay, and they're a way of modifying a system. And another thing to note here is look at the system. When I wrote this equation, I rewrote the x, y, and z, x, y, and z, x, y, and z. I rewrote all the x, y, and z, x, y, and z, x, y, and z. I was having an x, y, and z party here writing so many, but it's kind of redundant. Because those positions are never going to change, it's possible that we could have done this whole process without having to write x, y, and z 1,000 times. And so what you could do is you could just abstract from this just the coefficients, just what's important. And so you could say, hey, you know what? Well, let's do it here. See, I don't know if I can do it here. Alternatively, let's say alternative, yeah? Let's say alternatively. So alternatively, what we could do is, what I could do is I could just copy the essential information. I'm going to copy the essential information by writing here the 10, the 20, the 10, and the 50. And I'll write here the 1, the 1, the 1, and the 8. Of course, I'm just looking at these coefficients here and the coefficients here because that's the essential information from this. I know that this whole thing is the x column. I know that this whole thing will be the y column. I know that this whole thing will be the z column. And I know this whole thing will be the right side. So I'm not even worried about it. I'm just writing the essential thing, which would become -3 here, y here, 1 here, and 7 here. And I put these boxes around it like this, and this is called a matrix. Matrix just means a little cute box full of integers, or they could be even polynomials themselves, or it could be even matrices, a matrix of matrix. Whoa. But anyways, it's just an organized table of values. That's what we call a matrix. Usually it's rectangular. And usually, this would be a 3x4 matrix. It's a rectangular box, 3x4. It's a table with 12 values, 3x4. All right, but I can carry on the same sort of operations here that I had before. For example, I could do an elementary row operation here of, say, multiplying this whole thing, multiply by 1/10, right? And that would give me the following matrix. That would give me, the other rows are not changing, so I might as well just write them the same. 1, 1, 1, 8, -3. Whoa, I should have, nobody said anything about this. What the hell? That should have been a 1. All right, 1, 1, 7. And then the one that's changing, would, of course, would be just 1, 2, 1, 5. And that's what happens when you do that first elementary operation. The other thing I could do is I could add to this one. I'm doing it different than what I did before, just to show you how there's like 20,000 different ways to do this. I'm going to add to this one. 1 times row 1. Actually, negative 1 times row 1. I'm going to add to this one. 3 times row 1. And if I do that, I will get the following matrix. Nothing will change on the first one, so I might as well write it over again. This one will become negative 1. So I'm doing negative 1 times that. And then add it to that. That will give me 0. Negative 1 times this, and then add it to that. Negative 1 times this, and then add it to that. Negative 1 times this, and then add it to that. That's what I'm doing. And it's similar for that guy right there. So the first one would just be 0, negative 1, 0, 3. For the next one, it would be 0, because I'm multiplying everything by 3. 3 times 2 is 6. That would give me a 7. 3 times 1 is 3. Added to that, that would give me a 4. 3 times 5 is 15, 22, when you add it to that. And there you go. What that did, it did something super nice for me. I got all zeros here on the first, under the X column. I want zeros here. So what I could do is I could add to this one. Well, I like blue here for my operations. I'm going to add to this one. 1 times row 2. Now, if I do that, watch what happens. If I do that, by the way, I'm leaving everything else alone because this is all about adding stuff to the third row. Nobody said I'm doing anything to the second row or to the first one. So I might as well just write the other ones, the ones that I'm leaving alone. Now here I'm doing 7, I mean. Sorry, it's late. I'm going to do 7 times row 2 and add it to it. Now, what would happen when I do that? Of course, this would be 7. 7 times this, added to that, that would give you 0. I want that 0 to be there. Right? We want that 0. So this will give me a 0 here. This will give me a 0 here. This will give me a 4 here. Now I need to do 7 times 3. It's 21. 21 added to that, that will give me 40 something. And now, guess what? Now I have my echelon form. This is exactly what I was wanting. I wanted this pattern here so that only the leading things have values. Now I can convert back to, let's convert back to a system, because here what we have is a matrix. Sometimes this is called the augmented matrix. Well, this is a row reduce. This is called row reduce or echelon reduced matrix. This is called the augmented matrix. And then these are called elementary row operations. And then you get something beautiful. And then you can convert back. You could convert back to the system, and now you'll have something like this. 1x plus 2y plus 1z is equal to 5. I got that from just looking at the first row. 1x plus 2y. This is the x column. Sorry. This is the x column. This is the y column. This is the z column. Just like we had before, this is the right column. So that's how you're able to, just by looking at the first row, I get that. Now I'm going to look at the second row and get a second equation. And I look at this and I'll get a third equation. So I'll have negative 1y plus 0z is equal to 3. And I'll have 4z is equal to 43. And this one you can solve with your left hand. This is a piece of cake, duck soup. I'm not even going to solve because it's just too boring to do that. But this is beautiful. This shows you why elementary row operations are so useful. And the strategy to convert any kind of system into a row reduced system that's got the echelon form going, and it's pretty easy to solve. All right, I think that's a pretty good introduction to the basic ideas. You can get the rest of the other ideas from any textbook. I'm sure there's like a gazillion different videos too on YouTube. But I just wanted to get the main points out. Thank you. We'll see you guys next time.